Hi Year 12, this is the first of 5 videos for the topic of transformations. In this first video, we're going to look at translation. So here's our topic outline. We're going to review the graphing of functions, then we're going to look at translations, dilations, reflections, combinations of transformations, and then applications. So recall, the graph of a function is given by y is equal to f of x. And we write it like this because remember f of x is our function notation. It doesn't appear on the vertical axis. Y does. Now when we sketch, we use a third to a half of a page and we label the axes, x and y. We put an appropriate scale on the axes and we make sure that they're consistent. We label intercepts where appropriate. Sometimes we don't have to label the x-intercepts. And we label significant features like turning points, inflections, and asymptotes. So here's an example. You can see that I have written the equation near the graph, and I've labeled the x and y axes. The intercepts are clear, and I've also labeled the significant points, which in this case is the minimum point and the maximum point. And the scales are clear and consistent. You can see across here, the x-axis scale is consistent within itself, and so is the y-axis scale, but they don't have to match one another. Now recall, the domain is the set of allowable x values, and it can be the natural domain, or we can restrict it. And the range is the set of achievable y values. So having a look at this graph here, we can say that the domain is all real x, everything from negative infinity all the way up to positive infinity. But the range goes from and includes -4 all the way up to infinity. And these are both written in interval notation. And recall that an asymptote is a line that a curve approaches but never touches. And we draw them as a dotted line. So this curve here, which is in hyperbola, has 2 asymptotes, a vertical one and a horizontal one. Now functions like hyperbolas, exponentials, logarithms, and some trig functions like tan will have 1, 2, or multiple asymptotes. Okay, let's move on to transformations. Now we can perform transformations on a graph to produce a related graph. And these include translations, dilations, we sometimes call those stretches or compressions, and reflections. Now, another transformation is a rotation. We don't have to cover that in this course. Now let's just go back to Year 7 for a minute. If we move a point or a shape through a transformation, the resulting point or shape is called the image. So here we can see we've taken this shape and we've reflected it in the x-axis, and we have a new shape here. So this is the image. The original point or shape is called the pre-image. Now the new point, it has the same letter as the old point, but it has an apostrophe after it. And if there are multiple transformations, then we will use multiple apostrophes. Okay, let's look at translations. A translation shifts the graph either vertically or horizontally, but the shape of the graph remains the same. So here we can see a vertical translation. It's just shifting the graph up or down the y-axis. And here is a horizontal translation. It's shifting the graph along the x-axis. Right, let's look more closely at vertical translation. If we're given y equals f of x, then y equals f of x plus b will translate a graph vertically by b units. We can see that here in the picture. Here's y equals x squared. When I add a 1 to the end of it and get y equals x squared plus 1, that's going to shift my graph up 1 unit. So if b is greater than 0, the graph moves up. If b is less than 0, the graph moves down. And vertical translation can affect the range, and it has here. The range of this original function was 0 up to infinity. Now it's become 1 up to infinity. And horizontal translations. Given y equals f of x, y equals f of x minus a in brackets will translate a graph horizontally by a units. And we can see that here. Y equals x squared shifted over 1 to the right becomes y equals x minus 1 all squared. Now, if a is greater than 0, the graph moves right, and if a is less than 0, it moves left. But another way to think about it is this. Have a look at your transformed function and think about what makes 0 in these brackets. Well, x equals 1 makes 0, so that means this graph is moving over 1 unit to x equals 1. Now, horizontal translation can affect the domain. It doesn't in this case. Do you know why? Because parabolas have a domain of all real x. So that's the domain here, and it's also the domain here. Here's an example. Find the equation of the transformed function if y equals x minus 3 all squared is translated 4 units up and 2 units to the left. Now, 4 units up, that's really easy. We just add a 4 to the end of the function. But 2 units to the left, that 2's got to go inside here. And remember, our basic horizontal translation looks like this. F of x minus a. So 2 units to the left, that's negative 2. So we want x take away negative 2, which is the same as x plus 2. So this is what we want. Have a look at that and make sure it makes sense to you. Here's our plus 4, 4 units up, and there's our plus 2, 2 units to the left. So our transformed function is y is equal to x minus 1 all squared plus 4. Okay, our last question is on domain and range. Now remember, horizontal translations can affect domain and vertical translations can affect range. Here's the question. A new function g of x is found by translating f of x, which is equal to the square root of 1 minus x squared, 2 units down and 1 unit to the right. Find the new domain and range. Okay, we're going to start by sketching this, which is a positive semicircle. So drawing it up here, we have got semicircle centered at the origin with radius 1, so it goes between negative 1 and 1 on the x-axis and between 0 and 1 on the y-axis, and that gives us our domain and range. Now, if I want to shift that semicircle 2 units down, that's going to affect the range. It's going to drop it down the y-axis, so the new range will be negative 2 to negative 1. And if I want to shift it 1 unit to the right, that's going to affect the domain. It's going to shift this to the right 1 unit. So the new domain will be 0 up to 2. Okay, that's it for this lesson. Our next lesson, which is a bit of a tricky one, is on dilation.